How's it going, guys? Angus here from Makers Muse, and in today's video we are taking a close, detailed look at the latest Kickstarter sensation, the M3D Pro. So this has been madly requested by you guys. Everyone wants me to have a look at this campaign, so we're going to do it. But this is going to be a little bit different to my previous Kickstarter campaign videos where I look into 3D printed Kickstarter campaigns, because M3D is not new to Kickstarter. It's not this new company that's just shown up out of nowhere. They were on Kickstarter in 2014 with the M3D Micro. And this is interesting because it means there's some things I'm going to criticize them more on in terms of their new campaign, and some things I'm going to criticize them less on in terms of their reputation and actual legitimacy as a real entity. Anyway, let's get started. So I'm not going to put you through the entire video of their Kickstarter campaign, but as usual, it's got that sort of nice Kickstarter-y music, and it goes through some nice shots with pulling focus and all that sort of thing. There you go. And some people being interviewed about their new product. So the M3D Pro is the successor to the M3D Micro, which was one of the cheapest, if not the cheapest at its time, 3D printer you could get back in 2014. So I have talked to many people with M3D Micros, and in fact, many of you guys have said, Angus, why haven't you reviewed one? So a little bit of backstory. I approached M3D early this year, I think it was, and I said, hey guys, heaps of people want to see a detailed review on my channel of your printer. Do you want to send me one and I'll do a detailed, unbiased review? To which they replied, hey, we're a young company and we can't send out review units. We can give you a $50 discount. And then they sent me loads of marketing stuff. To which I said no. And that's where I left it. So that's why I haven't ever reviewed an M3D, but loads of you guys have gotten in touch with me. Also, I met probably 5 people at the Sydney Maker Fair who have M3D Micros. And I have to say, this is just from my opinion, they do not have a good reputation. So they were cheap, they do use cheap components, but from what I've heard from people, they really didn't live up to expectations. And if you want to see that in person, you can head over to their previous Kickstarter campaign and look in the comments section. But also just keep in mind that people will tend to post negative things, and if they're having a good experience, they just won't post at all. So it's not really a good representation, but at the same time, it's worth having a look through. Moving on, the M3D Pro is a new machine, so I'm not going to treat it like the M3D Micro, I'm going to treat it like a new project. So let's have a look through it. So, features. This is the big thing about 3D printing, and also this is where these sort of companies and campaigns can kind of try to blind you with marketing jargon, so let's cut through that. Large build volume. Large, okay. Print object up to 7.5 inches high, or tall, and 7 by 7 inches wide. So, let's grab a ruler. There we go. So that would be that. So that's about, 190 millimeters high, and about 180 side by side. So that's actually not too bad. If you're looking at the, like the Wanhao i3, that's 200 by 200 by 180 millimeters. I'm going to talk in millimeters, sorry guys, it's the only measurements I truly understand. So that's actually not too bad, and it's saying the outside dimensions of the entire product is 10.5 inches, which would be that. So that's a pretty small machine, and you're getting a lot of build volume for the size of the printer, which is pretty cool. I do appreciate that, and I always did like the aesthetics of the M3D printers. They have a nice cube, glossy plastic look to them. It is pretty cool. Accuracy, 25 to 350 micron layer heights with a 0.4 millimeter nozzle. That's the marketing jargon right there. 25 micron layer heights? Are you kidding me? Like, your nozzle's 0.4 and you're going to try to print at 25 micron? That's 0.25 millimeters. This is where these things can really confuse you, and I made a whole video about layer heights versus nozzle diameter, which you can click there to clarify this. But essentially, you will never be printing on anything much below 100 or maybe 150 microns. And usually I print at 250 on most of my machines, because obviously if you halve the layer height, the printer takes twice as long. So on a small machine like this, you might be printing at 100 a lot, but you're never going to print at 25. That's just pure marketing jargon right there. 0.4 millimeters is a really standard nozzle size. That's nothing unusual there. And yeah, doesn't really actually say anything as to actual accuracy in terms of tolerances or anything like that. Plus or minus, there's nothing there. And I would say with the design of the printer, the way it has, I'll go into it later, but it's got a really quite clever method of moving the head around. You're going to get some slop in that. And it doesn't mention anything as to what that slop would be. Next, standalone mode. This one makes me laugh. Okay, M3D software will automatically start printing and transfer print jobs to an internal memory chip, allowing the print to continue without being tethered to a computer. So, tethering a 3D printer like the Tiny Boy, which is over there somewhere, you have a printer, and you have a computer, and you have a USB cable, and the computer will send the G-code commands bit by bit to the printer. If the computer goes to sleep, the printer dies. This is how the original M3D Micro had to function. You could not do it, you could not print any other way. And I hate tethering. Tethering is a joke. You know, some prints can take 5 hours, and your computer has to be on that whole time. So, most other printers on the market use an SD card, or printers will have what they're saying here, an internal memory chip, like the Up Box and the Up Mini. They all have internal SD cards or internal memory that you cache your entire print job to, then turn the computer off. Makes a lot more sense, and to be honest, it's a joke that this wasn't included in the first place. So yes, standalone mode, that is nice, but really, yeah, what are you doing? Anyway, heated print bed. This is a big plus. So the original M3D did not come with a heat bed by standard, out of the box, and you need a heat bed to print really anything beyond PLA. You can't print ABS on a non-heated bed of any size. Chuck over on his channel does manage to print ABS on his Tiny Boy, the Fabricator Mini from Hobby King, which is pretty cool, but only in a very small print volume. Anything bigger, you're going to get warping. And even in PLA, a heat bed can improve your print quality by sticking it down on all corners. So, heat bed by standard is really cool, and it's good to see. I did read through their campaign. It does say it will do up to 100 degrees C, apparently, which will let you do ABS, which is pretty neat, so that's pretty cool. Fast printing typically prints filament at 60 millimeters per second or travels at speeds up to 120 millimeters per second. I usually print on standard on all my machines at 60 millimeters a second, but some machines can go faster. I would say, looking at the motors they're using, 60 is a little bit optimistic because stepper motors, the faster you push them, the less torque you get out of them. It's actually like a pretty drastic drop off. If you push them too far, you'll just lose all torque. So I would say you're more realistically going to be printing at 30 on this machine, looking at the size of the motors, and it also depends how fast the actual extruder can push plastic through. And rapids at 120, that's actually pretty slow for a rapid. Most machines can do 300. But it's a small printer, you might be able to get away with it. Third-party filament. Right, compatible with all industry-leading 1.75mm filaments, including particle-filled and high temperature. This one upsets me a little bit. So, particle-filled, you're looking at stuff like bronze fill from ColorFab, brass fill, also the XT-CF20, which is their amphora blend with carbon fiber filament particle. It's not actual filament, but it's got carbon fiber dust in it, however you'd say it. That stuff is super abrasive. If you have a bronze nozzle, it will chew it out in no time. I can't see anywhere in this, I might be wrong, it's a lot of jargon in here. I can't see anywhere in here where it's saying it's using anything harder than a brass nozzle, or actually saying anything about the nozzle. So using a particle-filled PLA or any other thing with harder particles than the actual nozzle itself will damage that nozzle. And in the original M3D Micro, the heater, the ceramic heater assembly was like individually tuned to that printer. I learned that through Zach's review over on his channel, Zach Blog. Check it out. And that meant they didn't want to send replacements. So I'd be really careful on this machine of printing unusual filaments. Do not buy this machine, I would say, if you're looking to print weird things like ColorFab's bronze fill, brass fill, or even flexibles. There's not really any evidence here that it will do flexible materials, and they are difficult to print. At high temperature materials up to 270 degrees C, I would bet that this machine will have a Teflon or PTFE lined hot end. 270 degrees C at an extended period of time will degrade that PTFE lining pretty quick. So, keep it in mind, I wouldn't use this machine on anything beyond ABS temperatures. And next one, embedded recovery mode. The M3D Pro can recover from print failure such as power outages, pauses, and filament shortage or jams. That's pretty handy, and a lot of machines on the market are now starting to say they offer this. So if you look at the Robox from CEL, that machine can sense if a filament is not extruding properly, if it's sort of slipping, or if the filament runs out, it will pause, which is cool. A lot of machines are now starting to have that sort of feature, and power outages is actually something pretty cool. I've looked at a few machines now that will remember where they got the power cut off. The Be the First Plus from Be Very Creative. Didn't like the machine overall, but it did have that feature, which was very, very cool. And the new Up Mini 2 and a few other machines that I know of will have this feature. So it's starting to become more common. I think it's just something that people have worked out how to include it, where it just keeps track of where the G-code was before it loses power. But that is handy. Sometimes power does get cut, and if you're in an area where power's sketchy, you might want to look into that, or look into a UPS, to be honest. This machine's pretty small. You probably could run it off a UPS. And finally, advanced sensor networks. This sort of feeds into the same thing. They're saying that this machine will have the world's first dual ARM processor system, fusing data from more than 24 sensors to provide industry-leading consistency and reliability. I can get behind that. It sounds a bit market jargon, but if the machine can keep track of what's going on inside it more accurately than other machines, you're likely to get less failures. But again, we're yet to actually see that in action. And that's the thing. With Kickstarter campaigns, again, guys, like all other Kickstarter campaign videos I've done, you pledge into these campaigns at your own risk. They are little more than a donation at this stage. And in this campaign specifically, M3D say they will not offer refunds because this is not a store. So you have to be really careful to keep in mind, are you okay with the chance of losing your money or getting back something you didn't actually expect, or it's not up to what you wanted? And Kickstarter campaigns, no matter what they are, have that element of risk. Sometimes they don't deliver, sometimes someone spends the money on a house, sometimes they go broke before they can deliver. You never know, and it's always that risk, so keep it in mind before you pledge. Moving on. So something I do like about the M3D design is it's very clever in how it controls the print head. So it's got these 4 vertical rails for the Z direction axis, but it's got these other little rods here, and they actually have a spline on them. And by turning motors underneath the print bed, it controls the X and Y axis in the print head, which is actually pretty clever. But by doing that, you're going to get a bit of slop from those splines, which means your print accuracy will suffer. And in some of their videos, you can see when it does a square, some of those edges where it's reversing the direction of the spline, it's not a clear 90 degrees. It actually has a bit of a slop in it because of that design, I suppose. But anyway, let's dive back into their campaign. So what I want to look at now is what rewards are on offer and what their deliverability expectations are. So, pledge $399 or more to get a M3D Pro deep discount. All gone. These got snapped up crazy fast. And it's worth mentioning again, because this is a Kickstarter project, they have a goal, $100,000. They're currently at $366,000, which is nuts. It's not the biggest 3D printing campaign ever, but it's certainly pretty damn high. And their goal realistically was actually pretty low. $100,000 to develop a brand new printer is really not that much. So yeah, $399 is gone. So what's the actual price? Like, how much do you have to pay? $449, all gone. $499. So that makes the M3D Pro a lot more expensive than its baby brother, the M3D Micros. $499 US could buy you on the current market a Wanhao i3 Plus, probably, or at least an i3 version 2.1. It could buy you, what else? It could buy you any kit. It could buy you more than 2 Fabricator Minis. It could buy you a printer I'm testing at the moment, which is the Keydi Tech X1. You can get a lot of good quality ready-to-run printers with sheet metal frames and single extruders at least for that price point. So $499 isn't really that magic number. I mean, recently we've had the Trinus 300 US. We've had the 101 Hero under $100 US. So $499 US isn't really that impressive to me. I mean, yes, okay, let's look at the facts. They have to develop a new printer, they have to pay their staff, they have to source things from China, they have to pay to send people to go to China to keep track of quality control. They are manufacturing in the US, they do state that, which I can highly respect, but it's still pretty expensive. So let's look at what they're calling the dramatic differences in terms of the M3D Pro versus the M3D Micro, and I'm going to weigh up these new differences versus other printers in the market at this price point. Okay, Pro sensor network. I've already gone into that. A lot of printers now start to have filament sensing and bed level sensing and that kind of thing, so it's not too unusual, but I do like the idea of a printer that can be more self-aware. So, well done to those guys for actually trying to get it to work, and I hope that it does actually work. Print speed. So they mentioned a print speed of 60 millimeters per second and then rapids of 150 millimeters per second, and it comes down to the sort of motors you're using. Most 3D printers on the market use NEMA 17s or NEMA 17s. They're quite large, quite bulky, and fairly high in terms of torque. The M3D Micro went a different route. It went with geared stepper motors, so you can get away with a smaller motor because you're gearing it down. I think it was like 60 to 1, but it means you have a smaller motor which is turning faster to move something slower, but with a multiplied torque. That's how gear reductions work. So they're saying they're moving to different motors. So they're saying we've had 3 years to improve motors through firmware, electronic hardware, and software optimizations, allowing them to move faster. Okay. They got a picture here, or actually a video, of a motor spinning quite fast actually. But again, as I said before in this video, stepper motors, you can push them to very high speeds, but they lose a lot of torque when they get to those upper ends. So this motor spinning very fast on a bench means nothing to me, to be honest. This motor, for all I know, as soon as you touch the shaft, could lose steps. And some of you guys might be wondering if this motor is actually a custom designed motor. It very well could be, but also it's possibly not, and I'll show you why. So here we are on Alibaba, and this is Main Texas store on Alibaba. So these guys manufacture these geared stepper motors, and they're used in all sorts of things. They're used in camera equipment, they're used in air conditioners, anything where you need to precisely control things, but you need something compact. So not very fast, but accurate, so you use a geared stepper motor. So here's their motors. They've got tons of different types. You guys might be familiar with the ones that are on eBay for like $2 each. That's one kind, but there is loads of different ones. Larger, more torque, different reduction ratios, heaps. They're brushed for some reason, they're there. But it's a clever idea to reuse existing tech anyway, and it's why they can get the price point lower. Right, and next second dramatic difference, highest efficiency heat bed. So the heat bed is a feature that's still not standard on most affordable entry-level models. Kind of disagree with that. Most printers at $500 actually have a heated bed, guys. So they're saying that typical heat bed uses 5 watts of power per square inch. I'm not going to do the maths on this, but judging from this video they've got, I mean, what is a heat bed? A heat bed converts electricity into heat. It is what it is. So in terms of an efficient heat bed, I think the only way you can make it more efficient is by transferring more heat in the right direction. So they might have some sort of insulator underneath it, bumping that heat upwards. But yeah, they've got this path here. It's actually interesting using like a FLIR heat vision system, thermal imaging camera, to show this. So you'd hope that the top surface actually has something that disperses that heat a bit more, because that's a pretty discrete heat zone. I mean, if you print with a corner here, you're going to get warping versus if you print with the corner there. So they're pushing it up to temp, and this is where it shows them able to actually hit, I'm not sure if it's 100, but it shows them able to hit a pretty high temperature. There we go. So it is warming up. Yeah, it doesn't quite hit 100 degrees C, but yeah, at a print volume that size, you probably could get away with that much printing ABS. And it's a glass print surface, so in my experience, glass doesn't work that great for ABS. Your experiences may vary, but there's nothing that would stop you putting a sheet of build tack or similar over the top of that and making it work. So yeah, pretty impressed with that. It doesn't show how the heat bed comes out. I'm hoping it just pops out, because you don't want to be retching on prints on the bed like with a scraper, but I wouldn't get your hopes up. It's probably secured to the printer. Third dramatic difference, comprehensive 2-year warranty. Woohoo! Printers break all the freaking time. Couriers smash them. People who don't know what they're doing break them. Printers break on their own. I mean, this happens constantly. 2-year warranty is something that you want. Let's read a little bit more into it. So, we know your time and money is valuable, and backing a Kickstarter project carries risk. Oh yeah, you might not get anything. And you might be unsatisfied with the quality of the product. Yep, that's possible. So they're saying they'll give you a warranty for 2 years, but it's a back-to-base warranty where you pay the shipping. Not so handy if you're in Australia and you have to send it back to the States, like in my case. And also, in terms of parts, you have to pay for them to send you parts. I can understand that from a business perspective. It's really expensive to offer warranty, but if a printer arrives broken, There's no way a customer should have to pay more money to get that printer fixed. And that's something I hope doesn't happen. That's something that I hope M3D takes on board. If you send someone a printer and something's wrong with it, it is not the customer's fault and it's not their responsibility to pay more money to get it fixed. And they won't cover consumable parts, which are obviously damaged by unusual or excessive force. So I can understand that if you rip the nozzle off and it breaks, that's your fault. But yeah, if something arrives broken or something breaks within the first 3 prints, which has happened to me on some other printers, it's not their fault. And they should not have to pay shipping. Fourth dramatic difference, tutorial mode. So it sounds to me that this is like a first use or walkthrough interface on their slicer. So it just walks you through all the modes. Most software should have this anyway. And yeah, I can understand this. People going for a low-end printer are unlikely to have much 3D printing knowledge. It's why I made my YouTube channel in the first place. So if you don't know much about 3D printing and you're watching this video, maybe check out my 101 series so you can pick up a bit of info. But yeah, not too much to say about that one. And fifth dramatic difference, M3D software features standard G-code support. Ooh, you don't have to use their slicer, which is great because their slicer wasn't very good for the M3D Micro after everyone I've talked to. Again, I haven't used it, I've just talked to a lot of people. So this is saying that you can use any G-code. Actually, it's saying it uses Cura as the backend, which is unusual because Cura is actually not that bad. So you can use Simplify 3D, which will be great. Octoprint, which is good for cloud-based printing. And other standard third-party slicers. Cool. And their sixth dramatic difference, Pro Filament and third-party filament. So they're talking about something here called ABS-R. I have not read into it, but it's probably not ABS. I mean, from what they're saying, it's like superior to ABS and PLA in every way. I don't know if it's actually ABS. It doesn't sound like it. It sounds like a PET or something like that. But again, I have no idea. I haven't looked into it. But it's saying what I really care about here is third-party filament support. As I said at the start of this video, I cannot see you printing carbon fiber-filled PLAs or those sort of materials through this printer without damaging something. And looking at their warranty, they'd probably say it's your fault. So I would be very careful as to what filaments you feed through this printer. It's by definition a delicate machine. It looks like a little bit less delicate than the M3D Micro, but still same idea. So don't put something through it that you think would damage it. Buy something like a Wanhao i3 where the print head can be completely opened by you, the user, and repaired, so you don't have to worry about it too much. But if you want to get this machine, and it does look a lot prettier, I would just stick to be honest, I will personally stick to a PLA Plus, like the ones from Polymaker or eSun. That's all I would run on this machine if I owned it. But if you're looking to buy it, be very careful as to what you try to push through it. As I said, I don't think it would print flexible materials very well, and I don't think it will print the metal-filled materials without ending in tears eventually. And just a few things that you might have missed within the very long list of things within their campaign is they're saying that domestic shipments will take priority, which kind of sucks because it should be priority based on who pledged first. And if I am here in Australia, I'm going to be waiting 1 to 2 weeks, probably knowing Kickstarter campaigns a month before they send it overseas. So whatever, that's just what they're doing. Keep it in mind. VAT is not included, so again, if you're importing something from overseas into Europe, you're gonna have to pay VAT, and your country may also charge other, whatever import duties. Kickstarter is not a store. We will not offer refunds. Again, as I said, you are pledging on an idea. There's no guarantee you're going to get anything that's any decent or anything at all. Keep in mind you may lose that money. And something pretty cool actually is they're saying the original 2014 backers pledging at or above the pro pledge level will get a 50% pledge credit. Pledge. So they're trying to entice previous backers in. Good luck with that. So guys, that's going to do it for this Kickstarter project, the M3D Pro, and my thoughts as to whether you should or shouldn't back it. Personally, it's not a machine that I would invest in. $500 US can get you many other printers already on the market. I could order one now and have it by the end of the week that already have the same or larger print volume, heated bed, and other features that I would like as someone who likes to tinker and a bit of a hobbyist. But if you don't want to work on printers, or you want something that's a bit more aesthetically pleasing, or you want to believe and buy into the hype of the sensor network that they're promising, if that does work, you will end up with a more reliable printing experience. And if that's valuable to you, well, yeah, maybe you should invest that $500. But keep in mind, it is a Kickstarter campaign. Nothing is guaranteed. Nothing is permanent. You may lose that money, or you may end up with an amazing 3D printer. I don't know, this is just my opinion based on my experience with working with 3D printers. So thanks for watching, guys. Hope you enjoyed this video here on Makers Muse. If you want to see other videos on 3D printing, tips and tricks, as I said, I do a one-on-one series, so if you just back this project and want to learn more about 3D printing, hit that link and learn a little bit more before your printer arrives. And I'll see you again next time here on Makers Muse. Bye.
Here's the latter half of the 20th century, and man has sent rockets into deep space. He has placed satellites into orbit, and he has actually walked in space.